was a little boy in the 1950s, there was a TV show on every Saturday morning that I'd never missed. It was in black and white, and it was called Mr. Wizard, the Science Guy. Fascinating, and it stoked my interest in simple do-it-yourself experiments. And here's an example that I have created in my latter years. It involves a simple copper coil that I made on a mandrel. I wrapped a 1/8-inch copper tubing on a mandrel, and then I cast this refractory insulation around it, and inside the bore is a 1/2-inch diameter cartridge heater, which has a thermocouple installed inside of it, which is connected to this solid-state relay controller. Right now it's off, it's not showing any temperature at all, but there's a thermocouple here and then a thermocouple on the inside, so I can measure the temperature on the outside. And then there are two ends of the copper coil that come through the wall of the refractory insulation. This is the inlet, and the outlet goes through a Tygon tube to a simple syringe I'm using as a plunger. I'll turn the furnace on. In a little while, it will be up to temperature. It's only set for 200 degrees centigrade. While I wait for the heating coil, the steam coil to heat up, I will demonstrate how to actually wind one of them on my mill, on my lathe. So I have two marks here that shows the beginning and the end of the coil that I want to make. I make the first winding by hand by turning the 3-jaw truck, and then on slow speed that's how it's done. Pretty cool, huh? The heating coil is now up to temperature at 200 degrees C, which is beyond the boiling point of water, or ethanol for that matter. The exterior of the insulation is at 50 degrees centigrade, so it's still cool to the touch. Well, warm to the touch. So what this experiment involves is filling a syringe with 40% alcohol by volume, which is basically just vodka. And what I will do is I will insert some of that liquid into the inlet of this tube and gasify all of the components. The reason for the 40% ABV is because that's the feed for an ethanol steam reformer. So I've already filled the syringe with this material, with this liquid, and I will attach this to the inlet. Right. Now watch what happens when I introduce just a little bit of this liquid into the tube. Now you can see it immediately vaporizes. Right? It doesn't take very much because steam is much greater volume than does liquid. Alright, so I've only introduced less than about a milliliter of liquid, and you can see the plunger coming in. I'll put a little more in. So I have a little steam engine, if you will, here. This is exactly how a steam engine works. Although I venture guess that the inventor of the steam engine had no desire to run his steam engine on vodka. But nonetheless, you can see the plunger goes up, and I'll stop there so I don't blow the top off. And it's hot enough to keep the gas inside in the vapor phase, and in a little while it will cool down and the plunger will drop as the water condenses back out, water and ethanol. That's my experiment. I've introduced about a milliliter of liquid into this expander, and you can see that I've got more than 50 cubic centimeters of gas. The syringe is hot to touch. So what I'm going to do is take a wet rag and cool it down to cause the steam to recondense, and there it goes. So this is the principle of a steam engine, and this is what James Watt would have been experimenting with some almost 300 years ago. Well, this is the principle behind a steam locomotive and any steam engine. Is the expansion of the gas, which does work, in this case, by pushing the plunger of the syringe up. And then as the steam is recondensed to water, it pulls a vacuum. Injecting water into the steam coil using a small syringe is interesting, but it's not very practical, since a steam engine requires a constant supply of high-pressure steam. To simulate this, I confiscated my family's Keurig coffee maker, took it apart, and donated it to science. This is the high-pressure DC pump that's inside of a Keurig. Works great for this application. It also works great for making coffee, but that's another matter. Now, this pump extracts water from this Nalgene jar and pumps it down through a valve so I can control the flow, and I've adjusted this valve to measure approximately 7 milliliters a minute, which is the maximum amount of steam that my 500-watt cartridge heater can handle. You can see here that the flow is on the order of 2 drops per second. To make steam, I'll connect the end of the water feed to the inlet of the coil, like so. You hear the steam starting to form. It doesn't make any noise, but it sure is hot. I will connect the exhaust, the outlet of the coil, to another tie-on tube that goes to a 100 milliliter syringe to collect the steam. And you see the piston starting to rise. The syringe has a hole in the top, so when the steam reaches the level of the hole, it will vent and not blow the piston out. You'll see in just a sec. So the water condenses and slows down the piston. And it will rise, it will continue to rise. Here it goes. There, you hear the steam venting out of the top of the syringe. So that's the steam engine. That's the idea. The steam engine using this 100 milliliter syringe is an example of an atmospheric steam engine that was first invented by Thomas Newcommen in 1712. James Watt created a steam engine in 1776 with many improvements, and I was able to purchase this wonderful kit from Retrol online of a Watt steam engine. So what I did in this case is I ran the output of the steam coil into the inlet of the piston block of the steam engine, prime it, started pretty fast. So this steam engine kit comes complete with a generator, like a little LED light once it gets up to speed.